Today we're going to start section 4.2, which deals with finding area. In order to do that, we need to go over how to use sigma notation for summations. Summations like 1 plus 2 plus 3 plus 4 can be written using sigma notation. So this funny looking E down here, that's a capital sigma. It's a Greek letter. The K down at the bottom is called the index of summation. Essentially, it tells you what the variable is and where you're going to plug your numbers into. So the K on the inside matches the K at the bottom, which means K is essentially the variable. That's where we're going to plug in our numbers. The 1 is called a lower summation limit, which means the first number I'm going to plug in is 1. And it doesn't have to be 1, it can be any number. The number in orange at the top, the 4, is called the upper summation limit. This is the largest number that we're going to plug in. So to get the expression that we have written at the top, 1 plus 2 plus 3 plus 4, if I start with k equals 1, I replace the k here with a 1, and then the next number after 1, 2, and so on until I get to my upper summation limit of 4. The value of this summation is 10. Let's take a look at some examples. This first one I'm going to do with you, and the second one I want you to pause the video and try on your own. So let's take a look at number 1. We want to find the value of the summation of I squared when I goes from 5 to 10. So I'm going to start by plugging in I equals 5 and write down 5 squared. Plus, I'm going to use all the integers going from 5 to 10. So then I have plus 6 squared, and 7 squared, 8 squared, 9 squared, and last but not least, 10 squared. If I add all of those numbers together, I'll get a sum of 355. So I'm just replacing the variable I with the numbers from 5 to 10. Please pause the video and try problem number 2 on your own. Okay, so let's see what you came up with. Our variable is k, so I need to replace the k's with the numbers from 3 to 7. So I'm going to start off with 2 times 3 minus 5 plus. Then I put in the next number, 4. 2 times 4 minus 5, and so on until I get to k is 7. Here we go, 7. And now I just need to find the value of those numbers. Well, the first number is really just 6 minus 5, which is 1. And the next one is 8 minus 5, which is 3. And I bet you figured out the pattern here is then plus 5, plus 7, plus 9, which gives you a total of 25. All right. In addition to being able to find the value of the sum, we need to be able to write sigma notation for a pattern. So we need to find the pattern between the numbers and then try to write it in sigma notation. So look at each individual number. When I look at the numerators, they are going up by 1. When I look at the denominators, they're going up by 1, which means I can easily write this using sigma notation because I'm going up by 1s. If I focus on just the number 1/2, well, that's 1 over 1 plus 1. Then if I look at the number 2/3, well, that's 2 over 2 plus 1. Does 3/4 follow the same pattern? And sure enough, it does. So I'm going to write that the top number is k, and if the top number is k, the bottom number is 1 more than that, k plus 1. Now, what number should I start at? The first number was 1/2, so to get 1/2 out of this expression, I need to start with k equals 1. The last number I have is 7/8, meaning I can have the top go as high as 7. Now, it's a good idea to always check your answer once you have written it down and plug in some numbers, especially at the beginning and the end, to see if you get the pattern that you were originally given. In this case, we will. Take a look at the second one. It looks like I'm squaring a number in each term, but then I'm subtracting something that is not always the same. Is there a relationship between the number being squared and the number I'm subtracting? This looks like it's 5 squared minus 3 times 5. The second one looks like it is 6 squared minus 3 times 6. If this pattern continues, then we're good to go. And sure enough, it does. If I look at the last term, I have 12 squared minus 3 times 12. So it looks like I'm going to have the number k squared minus 3 times the number 3k. And what number are we starting with? We're starting with k equals 5 and going all the way up to k equals 12. So there's the sigma notation for this pattern. One more example. Sometimes the numbers will alternate between positives and negatives, which makes writing the summation a little bit trickier. I'm going to have a -1 to an exponent in order to get an alternating. And that's because if I do -1 to an even number, I get a positive. And if I do -1 to an odd number, I get a negative. So I can get the alternating in there. If I ignore the signs, I see a 1, 2, 3, 4, 5, 6, 7, 8, which means I'm going from k equals 1 to 8, and I'm just doing the summation of k. Question is, what's the exponent going to be up here to get it so that I get a +1 and then a -2? Well, it has to alternate, so I'm going to need a k in there. So let's try this. If I plug in k equals 1, that gives me -1 to the first power times 1. Is that +1? And sure enough, it isn't. So if I try maybe adding on 1 to this, maybe I'll get the exponent I need. So now I'm going to plug in k equals 1 to this expression, and that's going to give me -1 to the second power times 1. Is that equal to +1? And sure enough, it is. Let's try plugging in k equals 2, just to see if we really have this right. If I do -1 to the k plus 1, that'll give me 3, and then I plug in k is 2. That'll give me -1 times 2, which gives me -2, my second term. And I know that when I plug in the next number, I'll get an exponent of 4, which makes it into a positive. So here is my pattern. Now the alternating ones can get pretty tricky, but they'll always have either -1 to the k power or -1 to the k plus 1 power. So hopefully that will be easy enough for you guys to figure out. In the next video, we're going to take a look at some special properties of summations and some formulas to use to make the process a lot easier.